Okay, as said earlier, we do cross negative axis. Okay, what is cross negative axis? If you remember all the, let's say this is the root locus, right? If you are crossing, typically what we are gonna do, okay, is to actually cross whatever axis. So we are trying to find whatever frequency that crosses certain axis. Let's say if you have this that you crosses this, so this point crosses the real axis, right? So I'm keen to find this point. How do I find? Okay, so in another example, if let's say I have a root locus that crosses two points, so I'm keen to find what is the omega over here and what is the omega over here, right? So how do I find? Okay, so this video, I'll just take this as a sample question. Okay, so instead of doing it in the back, I'll just do it in this video. I mean in this series of video, and then after which I'll just do out the rest of this. Okay, so this will be somewhat like a summary of what we're gonna do and sample questions. Okay, so without further ado, let's look at the transfer function, what it's trying to say. Okay, so so this video will try to introduce you to the thing first, and then we'll just start to do it. So the first thing first, when I read this transfer function, okay, I know that this is I have to first know that this is open loop transfer function. Okay, and then what I see is that I have two integrators. I have double integrator and I have a double leg, right? So from here you can actually visualize how the graph works. Okay, so maybe I should paste the thing. Okay, to visualize, what I need is to know what the angles that I have. Okay, so the first thing first, I have a plus 90 degrees over here because the zeros will contribute an additional 90 degrees. And then there is fourth order of the poles, right? So therefore we have negative 360 degrees. In this case, if you add it up, typically our root locus will be lying in will be somewhat like that. Okay? Not somewhat like that, but rather than it comes in from some directions. Okay, it comes in from some direction. Okay? If this is 90 degrees, minus 90 degrees, minus 90 degrees, minus 90 degrees. Okay, so this is one concept that I need to know. The second one is that, as you can see, this is s square. So this is a double. Maybe I should look at this first. Okay. So hold on. Okay, actually we don't need to look at anything now. Okay, it's just this root locus over here coming from some other place. So this is the positive. So while the negative should be somewhat coming in this direction. Okay, so yeah. Hold on. And then one thing to take note, okay? Because as you can see, this is 1 over s squared, right? So it actually flips the whole graph by 90 degrees. By 90 degrees. By hold on. Yeah. And then so let's say because the integrate, so this is the double leg, right? Double leg. So if you were to take, in this case, this is minus 180 degrees plus 0, which is 90 degrees. So the graph itself for without this one is actually at this portion over here. So the graph will look like this, right? But because you have a double integrator now, we are flipping it 180 degrees. So I just want to show you in a different visualization so that you can understand how things works. So if I were to flip it 180 degrees, okay, actually coming from here, right? So this is how I get back this. So in other words, I talk a lot, okay, just to show you that you just need to understand this contribute 90 degrees, and then look at the order. Okay, look at the number of orders. Okay, so you have fourth order times negative 90 degrees is poles. So if you sum them up together, you have negative 270 degrees. And then I can visualize what my locus will be. So it's coming from this direction, 270 degrees. Okay, minus 270 degrees. And the negative side will be this one. So when omega is equals to 0, it's somewhere in the in that zone, and then when it comes to infinity is here, and when omega is equal to 0, it comes over equals to minus infinity. So I hope I didn't confuse you anything. Okay, so if you were to compare it with our graph, I actually drew out the thing. This is actually what it is. Okay, actually my arrow, I drew wrong the arrow. Shit. So for this case, don't draw the arrow first lah. Okay, don't draw the arrow first because I haven't determined the magnitude. Okay, I don't know which side. Okay, so typically once you get this question, okay, look at the 90 degrees, look at the phase angle first, and then look at the magnitude. So the next thing we need to do is actually to calculate the magnitude first. Okay, and then in order to calculate the magnitude, if you remember the trigonometry rule, okay, this is the real axis, this is the imaginary axis, and then if you want to find the magnitude of this line over here, you're taking the imaginary square. So this, let's say we call this r square, okay, this length, and then we call this imaginary square. So r square plus imaginary square, we get a magnitude square. Okay, maybe I should square root lah. So yeah, so this is the magnitude. So the shortcut method we gonna do is actually to change this to that manner. Okay, as I said earlier, you have to isolate the coefficient 1. In this case, everything is 1, so it's okay. If let's say if it's 9 plus 10s, what you need to do is actually to change to 1 plus 10 over 9s, and then 9. Okay, and then you can calculate easier lah. Okay, but nonetheless, we just do it first like that. So what I need to do is actually to change the s equals to jw first. Okay, so if that's the case, I'll have j omega square, and then 1 plus j omega square. Okay, if you were to do it, okay, in a magnitude form, you will have 1 square plus 10 omega square, 100 omega square. Okay, because if you were to square this and square this, okay, that way that this j omega, this j is actually some unique vector saying that is in the y-axis. That's all. So you don't need to square this one. Okay, you don't need to square this one. So it's just the magnitude. Because this is real, this is imaginary. When you plot, it's just 10 omega. That's all, right? So you don't need to square the j. Okay. So I repeat again. This is the one big concept. Okay, no need to square the j. Okay, no need to square the j. So therefore, I have 1 square plus 10 omega square. I have 100 omega square now. Okay, and then divided by so I don't need to care about j anymore. Okay, if you're talking about magnitude, don't care about the j. So I have omega square, and then since I have 1 square plus omega, hold on. Yeah, so the magnitude itself within it is actually 1 square plus omega square. So it's within this, and then square root, right? However, because there is a square outside, so we can just cancel out the square and the square root. So therefore, we have 1 square plus 100 omega square, square root, omega square, 1 plus omega square. Okay, so this is actually the magnitude. Okay, and then if you remember, our phase angle is actually equals to 90 degrees. How do I get 90 degrees? So if you remember, this is the tangent. Okay, so typically don't write 90 degrees lah. Okay, when you know the 90 degrees is when you want to know how the plot will look like. But if you want to calculate for individual omega, okay, later you'll know why I have to do that. Okay, so let's say this is positive, so you just need to know that for zeros is contribute a positive tangent. Okay, and then omega divided by the real imaginary divided by real. Okay, so in this, and then minus away tangent, imaginary divided by real, and then minus tangent, because there is there's 4 poles, right? So I have 4 times of it, but they may be different real numbers, right? Because how do I say? Because as you can see, this is a real number. This is a anyway. You just need to know that you need 4. Okay, so just before I cancel away that square root, okay. So I have 2 degrees and 2 degrees. So this is actually for the omega. This is actually for another omega, and this is for the 1 plus omega square root, and then another one is for the another 1 plus omega square root. Okay, so simply said, this is that manner lah. Okay, so you just need to know these things. Okay, you may say that why if I cancel square and square root, I only have third order now ma. Yes, but in this case that before you convert into this one, you have initial 4 degrees of poles. So you need to straight away know that this is the thing. So there's a little dilemma there and there, here and there, but you need to know precisely how is it. And why I'm taking imaginary divided by real. Okay, if you remember, this is the real, right? And this is the imaginary, right? So any angle is determined by opposite divided by adjacent, right? So tangent theta is equals to opposite divided by adjacent. So this is opposite, this is adjacent. So definitely this is imaginary divided by real. And tangent so to find the data is equals to, okay. So therefore I have all this set. So this is the general equation. If I were to go furthermore, okay, I have, since you know that this is positive now, for the zeros part, imaginary is actually how many? We have 100, and then I have one real value, minus away tangent minus 1. For the omega side, there is no real value, so therefore the whole thing, you know, that is becoming to, so this whole thing will becomes to minus 90 degrees. Right, tangent inverse anything. So as you know, if this is 0, anything divided by 0 is infinity. So tangent inverse a very large number is actually 90 degrees. But since this is a pole, so you will contribute a negative 1. Same as this, because they're the same. So this is omega. So these two things contributes to this omega square, okay? And then these two things contributes to this square, okay? And then minus, because they are the same, so I can actually sum it up. 2 times tangent negative, and then since the magnitude is 1, so I have maybe I should put it in terms of omega lah. Okay. So with this set, okay, I have my phase angle, okay, and I have my magnitude. So this is where we stop. We will stop lah, okay. So this is our phase angle, and this is our magnitude. Okay, this is how I derive. Only these 4 sentences. I used 13 minutes to explain only this 4 sentences. Okay, but it's a pretty important thing. So I just need to highlight a few important notes that may confuse you. The first thing you need to know is to identify all of the poles and the zeros, number of poles and number of zeros. Okay, from there, then you can estimate your locus. I mean your nyquist plot. Okay, by the angle, the amount of angles, and then also the trend. Is it integrated or is it double leg? That's all. Okay, and then from there, the second is to actually straight away do the magnitude. Sub s equals to j omega, and then the key thing is that you need to know how to convert from this thing. Convert this thing to the magnitude itself. Okay, simply using the trigonometry rule, real and imaginary. So in this case, you have 10 j omega. In this case, it's actually 10 omega j lah. So this j is actually the imaginary. We have a 10 j magnitude. Okay, so 10 j square plus this is 1, so 1 square, and then square root you will have the magnitude over here. So this describes the magnitude over here. And then after that, you can solve for the rest. Then the third one you need to know is to do the phase angle. If it's zeros, okay, if it's positive 90 degrees, it contributes a positive phase lah, okay, not 90 degrees but rather than phase, because it is all determined by the number of the frequency. If the frequency increases, your degrees change. Okay, so later I'll just do our table, then you'll know what exactly we are doing. But so the phase angle wise, you need to be very clear how it's being derived. Is tangent negative imaginary over real, and then it's just the magnitude 100. Okay, 100 omega. Okay, 100 omega. Don't omega square. Okay, square is just the thing. Okay, actually this is actually 10 omega lah. Okay, so it's just taking 1 plus 10 omega j, right? So it's just taking the degree between this and this only. So actually I put wrongly. Sorry, my fault. So yeah. So I hope I did not confuse you anything. And this video talks about how to set up an equation, and then later on we'll talk about the rest of the thing. Later I'll just tell you about it. So I'll see you in the next video for future things.